Hi everyone, welcome to GoClasses. In this lecture, we will study Myhill Nerode Theorem. First, we will study the idea of Myhill Nerode Theorem, and then we will see the formal statement of Myhill Nerode Theorem. Okay, and we will prove that some languages are non-regular. Okay, we will see many non-regular languages, and we will also see if you have some language, then how can you prove that it is non-regular? If you have some language, how can you prove that there is no DFA which can accept some language? Okay, so that is our topic for today. Now let me start. Before we start, let me ask you some questions. Do you understand DFAs? What do you think? Do you understand DFAs? Now let me ask you some questions and you will tell me the answer. What about this statement? Is this statement true? Look at this statement. Is it true? For every string, DFA goes to exactly one state. Is this statement true? For every string, DFA goes to exactly one state. Okay. So when I say DFA goes to exactly one state, then what it means, basically what it means, from where? From where? From where? From initial state. When I say DFA goes to exactly one state, when I say DFA goes to exactly one state, when I say this, when I say DFA goes to, when I say DFA goes to, what this means? What this means? This means from initial state. When I say DFA goes to, it means from initial state. Okay, from initial state. Correct? So it simply means from initial state. Okay, now let's see. So on every string, DFA will go to exactly one state, whatever string you take, because remember in a DFA, what happens? In a DFA, you have whatever state you have, on every symbol, there is exactly one transition. On every input symbol. Okay, if your alphabet is A, B, then on every input symbol, there is exactly one transition. Okay, on every input, there is exactly one transition. For example, this type of situation can happen. Okay, on every symbol, there is exactly one transition. So this happens. Now you can notice, okay, this can happen. Now, I am saying that whatever string you take, you can take any string, A1, A2, maybe. You can take any string you can take. For example, W1, W2, W3. Okay, these are symbols. These are symbols. Let's assume WM or maybe WK. Okay, so here remember WI is belongs to sing. That is a symbol. So now you tell me, on this string where the DFA will go, on this string where the DFA will go, the DFA will start in the initial state. The DFA will definitely start in the initial state. And you can notice on every symbol, what will happen? On this symbol, DFA will go to some state, correct? Same or different? Same or different? DFA will go to some state. On this symbol, DFA will go to some state. Exactly one state. Okay. In this state, on this symbol, DFA will go to exactly one state. Okay. Finally, I can say that DFA will go to exactly one state. Okay, on every symbol. So if this is your string, then after reading every symbol, what will happen? After reading every symbol, DFA will start in the initial state. In this initial state, DFA, okay, will read this symbol. Okay, when you read this symbol, then what will happen? You will go to exactly one state, remember. Yes or no? Because from every state, on every symbol, there is exactly one transition. Okay, exactly one state. Because from every state, whatever state you take, from every state, on every symbol, there is exactly one transition. Okay, so you will go to exactly one state. Now, similarly, I can say that in this state, if you read this symbol, you will go to exactly one state. In this state, if you read this symbol, you will go to exactly one state, and so on. So I can say that DFA will end in exactly one state. Okay, DFA will end in exactly one state. So for every string, DFA will go to exactly one state. And if this is your state sequence, correct? This is the state sequence. I can say this is the state sequence. So what is the length of this state sequence? What is the length of this state sequence? That will be k plus 1. So DFA will go through a sequence of k plus 1 states. K plus 1 states. So every DFA on every string of length W will go through a sequence of k plus 1 states. So this is the idea, correct? Now we already know. Now, let's see. So for example, now let me ask you this question. Is this statement true? Is this statement true? For every string, can I say every state of DFA will go to exactly one state? Can I say for every string? Okay, tell me, for every string, so here actually this statement here says that, this statement basically says that delta star Q0 comma W for all W, for every string, what happens? for all w, delta star q0 comma w, that is equal to some state, that is equal to some state, that is equal to unique state, I can say that is equal to unique state. Okay, so this happens. Now here what I am saying, is this statement true? Yes. For every string, every state of DFA, okay, goes to exactly one state. So, okay, whatever state you take, okay, so whatever state you take, let Q belong to Q, okay, and you can notice W belong to sigma star. Then what will happen? For, okay, this I can say delta star Q comma W, Q comma W, that will be some state Q dash, I can say, and that also belongs to Q. So you will get a unique state. Again, you will get a unique state. Whatever string you take, again, you will get a unique state. So I can say for all W, this will happen. For all W, this is going to happen. Correct or not? Okay, yes, correct. So this is the idea. Now, from every state, this will happen. What about this statement? Is this statement true? Every DFA has finite number of states. Yes, every DFA that has finite number of states, you cannot have infinite number of states. Okay, now tell me about this statement. Tell me about this statement. If D is a DFA with n states, if there are n states, and then if S is any set of at least n plus 1 strings, if you have a set of n plus 1 strings, if S is any set of S plus 1 strings, n plus 1 strings, and there are n states, then at least 2 strings, okay, at least 2 strings of S ends in same state. At least two strings of S will end in same state. Is this true? Why this statement is true? Yes, because of pigeonhole principle. By pigeonhole principle, what will happen? If you have n states, for example, let's assume you have, this is your DFA. In DFA, you have total n states, Q1, Q2, Q3, and so on, Qn. Let's assume this is your Q. This is the set of states. Now you can notice from the initial state, what can I say? That if you have a set, some set you have, any set, I can take any set of strings. So some set you have which has some strings, maybe W1, W2, and so on, Wn plus 1. So total n plus 1 strings you have. So I can say this is some set of strings where each Wi is a string, where each Wi, that is basically a string. So what I can say? I can say that definitely you start, okay, DFA will start in the initial state, definitely correct. The DFA will start in the initial state. Now on W1, on W2, okay, it can go to different states, but how many states we need? Tell me. If we go to different states on every string, if we go to different states on every string, then how many states we need? If we go to different, then how many strings we need? Tell me. If we go to different, if we go to different, okay, if all of them are different states, if all of them are different states, like, okay, if all of them are different, means, for example, these strings, they are going to different states, then how many states we need? The number of states that we need, that will be, number of states we need is at least n plus 1, I can say. Then definitely number of strings will, number of states, how many states you need? At least n plus 1 states you need, correct? At least n plus 1 states you need. So it cannot happen, okay, it cannot happen. So I can say at least 2 of them will go to same state, yes or no? So at least 2 of them will go to same state. I can say at least 2 of them, at least two of them, at least 2 of, okay, at least 2 strings of S, I can say that at least 2 strings of S will go to same state, will go to same state, correct? Okay, very simple. Okay, so I can say, no, Alap, I am saying that these, I am not saying they can be same or not. Okay, they can, for example, you can also go to Q1. I am not saying that these are different from Q1. I am saying all of them are different. I am saying all of them are different. I am not saying they are different from Q1. I am saying all of them are different. These are different. Okay, these are going to different states. Okay, ending in different states. So if they are ending in different states, total n plus 1 strings we have. Total these many strings we have. And if they end in different states, if they end in different states, then you need at least n plus 1 states. Okay, it's like this. Let me tell you, for example, this is very easy to, this is very important to understand. For example, let's assume that, okay, there is a wedding house. There is a wedding in your house. Okay, let's assume there is a wedding in your house. Okay, so what is the initial state for your house? Like whenever there is a wedding, then what you do? Some hall you will book. Okay, so some marriage hall you will book. Let's assume this is the marriage hall. Okay, so some marriage hall you will book. In this marriage hall, some states, some rooms are there. So these are the rooms in this marriage hall. Okay, so and you can notice what is the initial state? Initial state is your house. So I can say your house is the initial state. You can put some people in the initial state, means in your house. So your house is the initial state. Okay, and there are some other state. So total how many states you have in this marriage hall? Total, let's assume n minus 1 states you have. So these are the number of states. Correct? Yes or no? So the initial state is your house. Some people, some important people, some close people, okay, relatives, they will stay in house, and your friends and other people, they can stay in the marriage hall. So finally, let's assume there are total n. Let's assume total n, including the house. Including the house, let's assume total n states are there. Let's assume. Okay. So it means total n plus n minus 1 rooms are there. Okay. Let's assume total n minus 1 rooms are there. And this is your house. One. Okay. So now you tell me, if there are some people, okay, like, okay, I can say uncle, maternal uncle, father, okay, like whatever. Okay. So maternal uncle, paternal uncle. Okay. So basically mama, chacha, tau, kaka, tau. So maybe whatever. Now let's assume there are some people and they have fight with each other. Now let's assume there are some people, they are fighting with each other. Okay. Now you tell me. So let's assume this is the set of people who cannot stay in the same place. Let's assume this is the set of n people, n plus 1 people, p1, p2, and so on, pn plus 1. So let's assume these are the set of people who cannot stay together in the same, they cannot. So tell me, or maybe I can ask you this question. Maybe let me ask you this question. If you have n plus 1 people, then what you can guarantee? If you have n plus 1 people, if you have n plus 1 people, then what you can guarantee? Tell me. If you have n plus 1 people and there are total n rooms, there are total n rooms. Okay, so I can say what you can say, if there are n plus 1 people, definitely at least 2 of them have to share a room. Can I say at least 2 of them, okay, have to share a room. They need to share a room. At least 2 of them, at least two of them must share a room. And this is very important point. Let me tell you. Now tell me about this one. So this is what I'm saying, that at least 2 of them must share a room. Okay, at least 2 people must go to the same room. Okay, from the initial state. Now you can notice here. So this is the point. Please understand this point, very important, very, very important. So if you have any state and you take any set, of at least n plus 1 strings, then at least 2 strings will end in same state. At least 2 strings will go to same state. Okay. Now, what about this statement? What about this statement? From every state will it happen? Can I say for every state Q, from Q, can I say that at least 2 strings will go to the same state? Again, this is also true. This is also true. Correct? In any state you start, it does not matter. It does not matter in which state you start. If you have total n plus 1 strings you have. Now, if you start in some state, if you start in this state, it cannot happen that you are going to different. Okay, from state Q, in this situation, Q1 was initial state, but now I'm talking about any state. Okay, so you can notice at least 2 of them must end in the same state. I can say at least 2 of them must end in the same state. This is what I'm saying. So at least 2 of them. Okay, at least 2 of them, I can say at least 2 of them must be same. At least 2 of S, at least 2 strings of S must okay go to same state, must go to same state from Q, must go to same state from, okay, from Q. Correct? Very simple. So this point is also very simple. Now you tell me about this point. If S is infinite set of strings, can I say this statement is true? If you have S is any infinite set of strings, okay, then can I say that for any DFA you take, now it does not matter what is the number of states in the DFA. Does it matter? Does it matter what is the number of states in the DFA? Does it matter? No, because number of states in the DFA is always finite. Number of states in the DFA is always finite. So now you can take any DFA. I can say at least two strings will go to same state because number of strings are infinite. You have infinite set of strings and there is a DFA. So I can say that at least two strings will go to same state. Definitely they will go to same state if you have infinite number of strings. What about this statement? Is this statement true? If S is any infinite set, S is any infinite set of strings, then for any DFA, for any state, from any state, at least two strings will go to the same state. This is also true because a DFA always has finite number of states. Now let me take some examples. Let me give you some examples. Okay, let's start with this example. This is your question. Let me start here. So let me call it state 1, let me call it state 2. So there are two states. Now you tell me, is this DFA? Is this a DFA? Let's assume this is your alphabet A, B. Is this a DFA? Yes, this is a DFA. Now you tell me, okay, now I am giving you some set. For which set what will happen? Like there are only two states. So you can notice number of states is 2. Number of states is 2. Can you guarantee if I give you any set of at least 3 strings, can you guarantee that 2 of them will definitely go to the same state? Yes. If I give you any set, for example, let me give you this set. Okay, randomly I can give you any set. For example, okay, consider this set. Let me give you some set. Okay, A power 100, B power 1000. Okay, so let me give you some random set. A B, A B, A B B B B A B. Okay, now you tell me. Okay, so can I guarantee without looking at the DFA? Don't look at the DFA. Can you guarantee? Okay, our DFA has 2 states. Our DFA has 2 states. Can you guarantee that at least 2 strings will go to same state? The DFA will go to same state on at least 2 strings. Okay, now you tell me which 2 strings. Which 2 strings? Which 2 strings? Okay, you like basically you can guarantee because your DFA has 2 states. Remember your DFA number of states in DFA is 2. Number of states in DFA, that is 2. So you can guarantee, this is very important, you can guarantee without looking at the DFA. You can guarantee, this guarantee is very important. You can guarantee without looking at the DFA, you can guarantee DFA will go to same state on at least 2 strings. Okay, DFA will go to same state on at least 2 of these strings. On at least 2 of these strings. On at least 2. Okay, and at least 2 of these strings. Now you tell me, so what are those 2 strings? Can you tell me? Can you tell me what are those 2 strings? First of all, the DFA is recognizing even number of A's. The language of this DFA is even number of A's. You can check even number of A's. Okay, so now you tell me. So here 1, 2, 3, 4, 5. Okay, so I can say that these 2 will definitely go to same state. The DFA will go to same state on these 2. So okay, so I can say definitely these 2 states will definitely go to same. I can say these 2 strings will go to same state. Correct? Yes or no? Now let me give you this question. Let me change the question. Now you tell me. Now all of them will go. But this statement is true, right? My interest is only at least 2. Can I say at least 2 will go to same state? My interest is only at least 2. Again, at least 2 are going to the same state. Actually, all of them are going to the same state. Okay, all of them will go to same state. But my interest is at least 2. Okay, all of them same state. All of them on all of them you will go to same state. Okay, but we only want at least 2. Okay, now you can notice. So this is the idea. Now tell me one thing. If I give you some DFA, this is my question. I don't give you the information of the DFA. If I give you some DFA with any states, okay, and if I give you some set S of n strings, I give you some set of n strings. Now tell me, can you guarantee these 2 questions I am asking? Can you guarantee at least 2 strings will go to same state? Can you guarantee? This guarantee word is important. Can you guarantee? Can you guarantee at least two strings will go to same state? At least two strings will go to same state. Will go to same state. So tell me, can you guarantee at least two of them will go to same state? So tell me about this one. So some DFA you have, I don't know, I don't have the information of the DFA. Some DFA I have with n states, okay, and some set of strings I have. So can you guarantee? No, you cannot guarantee, right? So definitely you cannot guarantee. The answer is no, you cannot guarantee. Now tell me this question. Now tell me this question. Can I guarantee that at, okay, all of them will go to different states? All of them will go to different states. Can I guarantee all of S, all strings of S, I can say all of S strings, I can say will go to different states? Can I guarantee this one will go to different states? Can I guarantee this one? Can I guarantee this one? Again, okay, can I guarantee this one? Again, I cannot guarantee. So what can I say? So if I have n state DFA and you give me n, basically this is my, so this is the point. You can notice if you have a DFA with n states, if you have a DFA with n states, and let's assume I don't have the information of this DFA, I don't have any information of the DFA, and let's assume S is a set of string, S is a some set of string, some set of less than equal to n strings, less than equal to n strings. Then what you can guarantee? Then tell me what will happen. S is some set of I can say less than equal to n strings. Then what we can say, where the DFA will go? Then we, okay, then DFA, then we cannot say anything. We cannot guarantee anything. Yes or no? Then we cannot guarantee anything. We cannot guarantee anything. Anything about the I can say strings, about the strings of S ending in okay same or different states, about the strings of S ending in states. Okay, so this is the idea. Correct? Is this clear to everyone? Okay, we cannot guarantee anything. We cannot, okay, we cannot guarantee anything. There is nothing we can say. We can say nothing. And from any state, and I can also say from any state. Okay, so we cannot say from any state, whatever state, not necessarily initial state, from any state we cannot guarantee. Is this clear? Okay, they may end in same state or they may not end in same state. For example, consider this DFA. Let me give you this DFA. So this is your DFA, A comma B. So sorry, A comma B, and let's assume this is also A, and let's assume this is B. This is state 1, state 2. There is no final state here. This is the state 1, state 2. But this is a DFA without final state. Okay, this is a DFA, and you can notice the set of final state, that is 5. Okay, now you tell me. So if I give you a set of 2 strings, like for example, let me give you set of 2 strings. One is, okay, one is this string, and let me give you another string, and let me give you another string, that is A power 100, B, okay, B, A power 100, B, A power 10, maybe, okay, maybe something 52, and then you have B, B. Now you tell me. Okay, so there are 2 states, and there are 2 states, and there are 2 strings. So what you can say? So you can say that they are going to different states. Yes or no? They are going to different states. So the DFA here for this string, the DFA will go to, okay, this string goes to state number 1, and this string goes to state, okay, goes to state 2. So you can notice that they are going to different states. Okay, they are going to different states. So this goes to 1, this goes to 2. Now, for example, if I ask you this question, now what is the answer? Now you can notice this is also going to 1, or this is also going to 1. Okay, so both of them goes to state 1. So we cannot say anything, right? This is the point. So if you have 2 state, if you have 2 string, you cannot say anything. So now you tell me. So this is a DFA, and this you can see. Tell me the next point. Okay, if I give you this set, let me give you this set where these strings will go. Let me give you some set S3. Let me give you a set S3, and this is, I can say, A power n, where n is greater than equal to 1. What can you say? Is this infinite set? This set is infinite, right? This set is infinite. So for this set, what will happen? For this set, what will happen? Your DFA is this. Remember, your DFA is even number of A's. This is your DFA. Your DFA is even number of A's. So if I give you this infinite set, then what will happen? I can say at least two of them will go to same state. What are those at least two of them? At least two of them will go to same state. Correct or not? So I can say at least two of them will go to same state. At least two strings. I can say at least two strings of S will go to same state. Will end in, will go to, or I can say end in same state. End in same state. Okay. So you can notice what are those. For example, I can say that I can say these two strings. Look at these two strings. I can say at least two strings will end in same state. At least two. Okay. So I can say, for example, I can say a power 40 and a power 58. Okay. So they will go to same state. Okay. End in same state. So they will end in same state, and that is state number 1. Okay. So what will happen? So I can say from state number 1, this is your initial state. From state number 1, you can notice that these two will go to same state. Okay. This a power 40 and also this a power 58. They will actually go to same state. I can say they will go to same state, and that state is 1. That state is 1, but they will go to same state. My point is only this, that they will go to same state, and that state is basically 1. Yes or no? Do you agree or not? Tell me. Is this point clear? So I can say at least two of them will go to same state. Okay. Because there are infinite number of strings here and you have finite number of states. So definitely at least two of them will go to same state. Okay. So this is the idea. Now let's see this one. In this question also, in this question, you tell me, I'm giving you a set. Okay. Let me give you some set. For example, a power n, b power m, where n is greater than equal to m. Where n is greater than m. Okay. Now you tell me, is this infinite set? This is also infinite set, right? So at least two of them will go to same state. This is your set. I am giving you a set of strings. Now, which two strings will go to same state? This is your DFA with odd number of A's. So at which two strings will go to same state? Give me two strings which will go to same state. You can guarantee that two strings are there which will go to same state. For example, you can take, I can say, for example, you can take a from this set. From this set you should take. From this set you should take. Alap, your string is not from this set. Alap, your string is not from this set. I am talking about this set. At least two strings of this set will go to same state. The idea is this. For example, I can give you these two strings. I can give you a power 100, b power 10. I can also give you another string. So which string I should also give you? So this DFA is odd number of A's. So you can notice I can give you a power 50, b power 2. Okay. So you can notice these two will go to same state. Can I say? So from state 1, I can say from state, let's call this state 1, let's call this state 2. So from state 1, what will happen? These two strings will go to same state. These two strings, a power 100, b power 10, and you can notice a power 50, b power 2. So they will go to same state, and that state is basically 1. Okay, so they will go to same state, and that state is same as 1, but they will go to same state. Okay, this is the idea. Now similarly, if I give you this string, for example, if I give you a power 1011, and if I give you another string, for example 51, now what will happen? So they will also go to same state. These two strings will also go to same state. Correct? These two strings. So basically I can guarantee that at least two strings will go to same state. So 1011, and you can notice this is your 51. So they will go to state number 2, but they will go to same state. And this is your DFA. This is your DFA, and DFA is accepting odd number of A's. This is your DFA. So where this DFA will go on the string a power this, on this string where the DFA will go, tell me. On this string where the DFA will go. This is your DFA. This is your DFA where the DFA will go on this string. Just tell me this point. On this string a power 1011, b power 10. On this string where the DFA will go. On this string where DFA will go. Tell me. Delta star where the DFA will go. Initial state is this W. So where the DFA will go? Where will the DFA go? So DFA will go to state number 2. Is this clear, Anirudh? Anirudh, is this clear? Like, let me give you another number, another df, another string. Let me give you another string, that is a power 51 and b power 2. Where the dfa will go, tell me. On this string, where the dfa will go, w2, where the dfa will go on this string. On this string also dfa will go to state number 2. Is it clear? Let me know. All these points, are they clear? Now tell me, can it happen? This is my question. Can it happen on your screen? Can it happen? Can it happen that some DFA, I am not giving you the information, this some DFA, any number of states, I don't know how many states, but this is my question. Can it happen that s equal to a power n? Tell me, can it happen s equal to a power n? N is greater than equal to 1. Some DFA goes to different states for different strings in S. Can it happen? Some DFA is there which goes to different states for different strings. Can it happen? The answer is no. Because if it happens, then what will happen? If it happens, that infinite number of states, yes or no? If it happens, then we need infinite number of states. We need infinite number of states. Okay, which is contradiction. Which is a contradiction or not possible, because every DFA has finite number of states. So this is not possible. So can it happen? The answer is no. This cannot happen. What about this statement? Can it happen? Can it happen? Again, a power n, where n is greater than equal to, okay, so basically this some DFA, there is some DFA goes to different states for different strings. Can it happen? Can you create a DFA which will go to different string? Remember, your set is this. Your set is a power 1, a power 2, and so on, a power 10. This is your set. Can you create a DFA which will go to different strings, different states on different strings? Can you create a DFA? Yes, of course, you can create. For example, you can create this DFA. Okay, basically, you want them to go to different states. These strings should go to different states. So what you can do, you can create this type of DFA. Let's call it Q0. Let's call it Q1. Okay, you can create this type of DFA. You can create. Let's call it Q3, and so on, and so on, and so on. So I can say that there will be something called Q10. Okay, so there will be something called Q10, and then finally you can go to some string. For example, maybe, okay, it does not matter. It does not matter what is initial state, what is final state. It does not matter. Okay, for example, I can do this. Now, can you notice? Please tell me what will happen in this DFA. In this DFA, what is going to happen? In this DFA, on these strings, this DFA is going to different states. Yes or no? This DFA on these strings, what is happening? From this string, from this state, from the initial state, and this is your language. Your language is a power. Your set is this. Sorry, not language. I am giving you some random set of strings I have given to you. Now, what will happen here? It will happen that they are going to different states. On double A, it is going to different state. On triple A, it is going to different states. Yes or no? Okay, yes or no? On a power 10, this is going to different states. So it can happen, right? It can happen. This is my question. Can it happen that some DFA, you can create some DFA, right? Correct? For this set, this is your set. For this set, I can create some DFA. I can create such that different strings will go to different states. Yes or no? Like this I can create. So you can notice on all these strings, a power 1, a power 2, a power 3, a power 10. So these are different states. So you can notice all of them are different states. Please tell me, if these points, all these points, are they clear? Because these are extremely important. I know you are thinking these are easy. I know you are thinking that these are very easy. Sir, why are you teaching these points? These are very easy and I am expert. Okay, but please understand these points. Don't have any doubt in these points. Now tell me about this one. Can it happen? Can it happen that you have this set, okay, and you have 1 crore? So basically you have 1 crore. This is your 1 crore. Okay, so can it happen that some DFA goes to different states for different strings? How many states you need? How many states you need? Okay, how many states you need to guarantee this? This is my question. How many states? Okay, so can I say this question? You are saying that this statement is true. You are saying this statement is true. So how many states I need? Okay, if I have, for example, this type of DFA I can create. So this statement is possible. Can it happen? Yes. Yes, can happen. Yes, it can happen, because what I can do, I can create this type of DFA. I can create Q0. I can create this type of DFA. Q0 on A, it will go to Q1. On another A, it will go to Q2. On another A, it will go to Q3. So on A cube, it is going to Q3, and so on, and so on, and so on. It will go to Q1 crore. It will go to Q1 crore. And then finally, okay, maybe I can create one more state. That is my choice. And then I can do something like this. Okay, that is my choice. So now you tell me, how many states? So you can notice, okay, can you notice here what is happening? Here, can you notice that this is what is happening on different strings? This is your initial state, and from A, okay, on A, then on A square, then on A cube, then on A power 4, and so on in A crore, on 1 power A crore. You can notice these are different states. This is going to different states. Yes or no? Different states. So this can happen, right? So now this is my question. Okay, can some DFA, so with some DFA with 1,000 states, some DFA with 1,000 states, can it do some DFA with 1,000 states? Now tell me the answer. Some DFA with 1,000 states. The answer is no. Why? What is the reason? Tell me what is the reason? Because your DFA has 1,000 states. Your DFA has 1,000 states. DFA has 1,000 states. Only 1,000 states you have. And you can notice your set has 1 crore strings. Okay, A power n, where n is basically greater than equal to 1 and less than equal to 1 crore. And you are saying that they should go to different strings. Like this is the, I can say these are the people. You have only 1,000 rooms. Okay, and these are the guests. And these are the guests. And these guests are saying that we want different rooms. These guests are saying we want different rooms. These guests, they are saying different rooms, wanting different rooms, wanting different rooms. So it is not possible, because you only have 1,000 rooms. So this is definitely not possible. Okay, now you tell me one more thing. So how many states you need? Okay, to guarantee this, how many states? Okay, what can you say about number of states? What can you say about number of states in DFA? To ensure this, number of states in DFA must be greater than equal to 1 crore plus 1. Number of states in DFA must, is this correct? Actually, 1 crore is enough or not? Is 1 crore enough? Is 1 crore enough? Is 1 crore enough? Yes, of course, 1 crore is enough, right? Because you can notice, if I give you, for example, if I give you this set, can I say 2 state DFA is enough? Should go to different state. Okay, should go to different state. Should go to different states. Should go to different states. Then tell me, can I create a 2-state DFA? Yes, of course I can create 2-state DFA. I can create, right? I can create 2-state DFA. 2-state DFA I can create. For example, I can create this DFA. Okay, where on A it will go here, on A it will go here. So 2-state DFA is fine. 2-state DFA is fine, right? You can notice from the initial state, on A you will go to 2, and on double A you will go to 1. So different states, you are going to different states. You are going to different states. So should go to different states. Okay, so I can say that 1 crore states is enough, basically. Okay, yes or no? So I can say number of states in DFA must be greater than equal to 1 crore. It should happen, correct or not? So basically, a very simple idea, yaar. Okay, very simple idea. You tell me, how many guests are there? So 1 crore guest, 1 crore guest. So how many rooms? At least how many rooms you need? At least how many rooms you need? At least how many rooms you need? 1 crore. Okay, if they want different rooms for different guests, 1 crore guest in this set, and they want different rooms. So 1 crore rooms you need. Yes or no? 1 crore guest, 1 crore, at least 1 crore rooms you need, at least. I hope all these points are clear. Is this possible? Can it happen? A power n, B power n, this is some set. Remember, S is any set. This is some random set. Some random set of string. This is some random set of string. Now, okay, so some DFA goes to different states. Yes, this is possible. Again, so the answer is again yes. Definitely you can create. Okay, because only, okay, so you can definitely create. For example, some DFA you have. For example, maybe I can say that this DFA you have. Okay, this is your DFA. And I give you some random strings I am giving you. Some random strings I am giving you. For example, some random strings A, B, A, okay. A, B, A, B, A, B, B. Okay, so some random strings I am giving you. Now you can guarantee that they will go, at least two of them will go to same state. Yes or no? This is you can guarantee. You can guarantee at least, because there are two states and there are three strings. So you can guarantee that at least two of them will go to same state. At least two of them will go to same state. Where this is going, tell me. Where this is going, A, B, A. It is going to state number 1. Where this is going, A, B, A, B. This is also going to state number 2. This is also going to state number 2. And this, and where this is going, B, B, A, B. This is also going to state number 2. So you can notice at least two are going to same state. Correct? At least two are going to same state. Okay, is this clear? What about this one? Is it possible? Is this possible? A power n, B power n. This is an infinite set. This is an infinite set. So can you create some DFA such that these strings will go to different states? So the answer is no. This is not possible. You cannot create a DFA. Okay. So I hope all these points are clear. So remember, some random set I have taken. Please understand that some random, so far, what we have done so far, what we have done, we have DFA. Okay, we have DFA. Some DFA you have, and some random set of string. Randomly I am taking some strings. Randomly I am taking some strings. Some random set of strings. Yes. And what we are checking? We are checking where these strings will go. So remember, we are taking some random set of strings. We are not taking language of the DFA. We are taking some random set of strings and we are checking where these strings will go. This is what we have done so far. Yes or no? Checking where these strings will go. Where these strings will go. Okay. So this is what we are checking. We are checking where these strings will go. So very simple. So this is what we have done so far. Now the question, the interesting question, can I say every language is regular? Means, can I say that for every language you can create DFA or NFA or regular expression? The answer is clearly no. The answer is no. There are many non-regular languages. There are some languages for which you cannot create any DFA. You cannot create any DFA. Okay. So you know that these things are equivalent. Like I can say L is regular. I can also say that L is accepted by some DFA. L is accepted by some NFA, or some regular expression is there for L. So these things are equivalent. Regular expression, I can say that DFA, the power of DFA is same as power of NFA, is same as power of regular expression. Every language that you can accept using NFA, you can also accept using DFA. You can also create regular expression for that. Any language which can be described using regular expression, you can create an NFA for that. You can also create a DFA for that. So all these things are equivalent. All these things are equivalent. But there are some languages for which you cannot write regular expression. There are some languages for which you cannot create any NFA. You cannot create any DFA. These languages, we call them non-regular languages. Okay. Now, so let's start with our first example. Let's see our first example. A lot of examples I am going to take, and please focus here. Please focus here. So let me start with our first example. This is our, let me start with this. Question number 1. Prove that this language is non-regular. Prove that this language, a language I am giving you, A power n, B power n. This language we have already seen. Do you remember? A power n, B power n, n is greater than equal to 0 or n is greater than equal to 1. It does not matter. It does not matter. This is a non-regular. Is a non-regular means there is no DFA. Is a non-regular means there is no DFA. So tell me how to prove it. Very easy. Very easy. What I will do, please understand, because I am going to take a lot of questions. Okay, and every question you understand what I am going to do. I am going to create infinite guest. I am going to create infinite guest who will demand their own room. Who will demand their own room. This is what I am going to do. Some random guest I am going to create. Okay, so I want to prove that this is a non-regular. So what I will do, consider a randomly I am creating a set. Consider a set S. So consider this set a power 1, a power 2, a power 3, and so on. This is an infinite set. Consider this set. Now tell me, is it possible? Okay, so let me assume, prove that this is non-regular. So let me assume there is a DFA. Let's assume there is a DFA. Assume there is a DFA. For a moment, assume there is a DFA. Assume there is a DFA. There is some DFA. I don't know which DFA. Maybe it has 1 crore state. Maybe it can have 1 trillion, 1 billion. I don't know which DFA. This DFA, maybe it can have 1 trillion state, 10 trillion state. Okay, 1 trillion state. Basically, I don't know which DFA, but I am assuming there is just some DFA. I'm assuming there is some DFA. Okay, there is some DFA for L. Okay, now you tell me. Of course, this DFA has finite number of states. Whatever DFA you have, this has finite number of states. Whatever DFA you take, it will have finite number of states. Whatever DFA you take. So I am assuming there is some DFA, and every DFA will always have finite number of states. So this has finite number of states. These are the rooms. These are the rooms. And these are the guests. So what you can guarantee? What you can guarantee? Infinite number of guests. So what you can guarantee? At least 2 of them will go to same room. Can you guarantee? Infinite number of guests, and this is a DFA. You can guarantee at least 2 of them will go to same state. You can guarantee. What you can guarantee? This guarantee is important. What you can guarantee? What is guaranteed? That at least 2 of them, okay, at least 2 of them will go to same state. At least 2 of S will go to same state. At least 2 of S will go to same state. Okay, so if now you can notice, now what will happen? So you can guarantee that at least 2 of them will go to same state. Now there is a problem. You are saying at least 2 of these guests will go to same room. You are saying this. So can I assume some randomly 2 strings can I assume? Let me assume, like for example, so assume that 2 strings will, okay, assume a power m, a power n. These two, where these two, let's assume these two are going to same state. Let's assume these are going to same state. These are going to same state. Because you know that at least 2 guests will go to same state. You guarantee. So for example, I can assume, right? I can assume for example, let me assume that this and let me assume this and this. Okay, let me assume they are going to same state. Correct? See, very one by one, I am telling you that this is the language. This is the language that is given to you. First, I am assuming there is a DFA. I am assuming some DFA is there. I don't know which DFA, but I am assuming some DFA is there. Every DFA has finite number of states, means finite number of rooms. Now I am considering a set. I am considering a random set of strings. So this set I am considering a power 1, a power 2, a power 3, and so on. This is an infinite set. So these are our guests. Now, because there are infinite guests and we have finite number of rooms, so I can guarantee that at least 2 guests will go to same state. At least 2 guests. Like, okay, let's assume these are the 2 guests and they are going to same state. From the initial state, they are going to same state. Okay, from the initial state, they are going to same state. They are going to same state. Now they are going to same state. Okay, this is what I'm assuming, because at least 2 people will go to same state. At least 2 people. So I'm assuming these 2 people are going to same state. Now there is a problem. Now there is a problem. Now, is there any problem? Now there is a problem. Now there is a problem. Is there any problem? How can you create a problem? Now there is a problem. How can you create a problem? Like the problem I can create like this. The problem is actually where this q will go on b power 100. Where this, tell me, on b power 100, this q will go where? How many states this q will go on b power 100? On b power 100, how many states? Only exactly one state. So now the problem is this, where this will go on b power 100. This is the question. This is the question mark. Where this will go on b power 100. If you say final state, then there is a problem. If you say final state, there is a problem. And if you say non-final state, there is a problem. If you say non-final state, there is a problem. If you say final state, there is a problem. If you say final state, what is the problem? If you say final state, what is the problem? Just tell me the problem. The problem is a power 501, b power 100 accepted. The problem is a power 501, b power 100 accepted. Yes or no? Accepted. Correct? Yes or no? And if you say non-final state, then what is the problem? Just tell me the problem. Then what is the problem? The problem is that a power 100, b power 100 rejected. Rejected. So whatever you do, there is a problem. Can I say? Can I say whatever you do, there is a problem? Yes or no? So this is the idea. So I can say, so whatever you do, there is a problem. What it means? It means there is no such DFA. It means there is no DFA which can accept this language. There is no DFA. There is no DFA which can accept this language. Yes or no? Is this clear? Basically, there is no marriage. There is no marriage who can allow these guests. There is no marriage who can accept this language. These, okay, so this language. So this is the point. So is this template clear? What I have done? This template is very important. Extremely important, this template. What is the template? What are the things I have done? So tell me, what are the things I have done? The first thing I have done, some language is there. I want to prove it is non-regular. So what I have done, the first thing what I have done, I am assuming there is a DFA. Okay, let me assume there is a DFA. Let me assume, I don't know which DFA, but I am assuming there is a DFA. Okay, so let me assume. Now every DFA, whatever DFA I assume, that DFA will have finite number of states. Okay, so now what I am doing, I am creating a set. I am creating a set of infinite guests. So I am assuming I have a wedding hall. Okay, I'm assuming there is a wedding hall in this world. Okay, but whatever wedding hall you take, that will have finite number of rooms. Then what I'm doing, I am creating infinite number of guests such that these guests, they cannot go to same state. No, okay, no two of them can go to same state. This type of guest I am creating. Yes or no? I am creating this type of guest. This type of guest I am creating such that no two of them can go to same room. I'm intentionally, this is my intention, remember, I'm forcefully creating infinite number of strings such that if any two of them, whatever two you take, if any two of them go to same state, then there will be problem. Okay, so what it means? It means that there is no such DFA. Yes or no? There is no such wedding hall in this world who can accommodate this type of guest. So there is no such DFA. Okay, I hope this point is clear. So this is the template. This is the complete template. Okay, so remember what we have done. This is our language. We need to prove that there is no, this is non-regular. So what I will do, I will assume there is a DFA, some DFA is there, and this is the language. Now, forcefully, I am creating a set. Consider this set. This set you consider a power 1, a power 2, a power 3, and so on. These are the strings. Now, what is the guarantee? The guarantee is this. At least two of them will go to same state. This is guarantee because there are infinite number of strings and you have finite number of states. So I can say at least two of them will go to same state. Now there is a problem. If at least two, you can assume any two. Okay, if you assume that two strings are going to same state, means your, I can say from the initial state, your DFA on these two, m is not equal to n. Remember, m is not equal to n. So two different states are going to same state. Now there is a problem. Now there is a problem. Now there is a problem. So if basically, if any two of them go to same state, there is a problem. If any two of them, whatever two you take, if any two of them go to same state, there is a problem. And what is the problem? The problem is this, where this will go on b power m. where this will go on b power m. So, for example, if you say final state, then problem. If you say final state, then problem. What is the problem? If you say final state, then what is the problem? A power n, b power m accepted. This is the problem. Remember, m is not equal to m. N is not equal to m. And you can notice if they go to non-final state, then there is a problem. Then also there is a problem. What is the problem? The problem is this, that a power m, b power m rejected. Okay. So you can notice whatever you do, there is a problem. Whatever you do, there is a problem. A power m, b power m, should this be rejected? This is your language. A power m, b power m, should this be rejected? This is your language. Should this be rejected? No, this should not be rejected. And a power n, b power m, where n is not equal to m, should that be accepted? No, because this is your language. So I can say that whatever you do, there is a problem. Whatever you do, there is a problem. Whatever you do on, okay, b power m, whatever you do, there is a problem. Whatever you do, there is a problem. So there is no DFA. So no DFA exists, I can say. So no DFA exists for L. Did you find this proof interesting? Did you find this proof interesting? This is the formal proof. Okay, today I was talking to one person, let me tell you. So this my friend Raja, his name is Raja. Okay, so my friend Raja, so he had I think 888 rank. Okay, so in GATE exam he had 888 rank, and still he went to ISC. He went to ISC. The reason is simple, that with this rank you will get, if you get this type of rank, for example, if you get top 1000 rank, okay, 700, 500, 600 or 900, if you get this type of rank, then you will get call from ISC for MTech research. There is a course, MTech research, very nice course. Okay, so for this course, this is a 3-year course. I can say, I think 2.5 years course this is. Okay, so this is a course, research based course. This is a very nice course. Okay, placement is same. The placement of this course is same as the placement of MTech course. So right now Raja is in Mindtree, this company. Have you heard about this tree? This company. So in this company, he's my friend, like, okay, he's a real person. So I was talking with him. So he got ISC with this rank, and the placement is same. The placement of MTech and MTech research, they are same. So you don't have to worry about it. Like, you don't have to think, oh, I will get this. Okay, both are same, exactly same. Let me tell you, here in this course you will get more knowledge. This course is research based, so in this course you will get more knowledge, and the placement is exactly same, no difference. Okay, now let me tell you that. So what he did, he went to ISC for interview. Okay, so for this course there will be interview. For this course there will be interview. Now let me tell you that many students who had this type of rank, 400, 600, many students, they did not get selected. This type of, okay, this type of rank, many students who had this type of rank, they did not get selected, and Raja got selected. What is the reason? Because in the interview they will ask you proof. In the interview they will not ask you like dumb questions. They will ask you proof. They will ask you only 3 or 5 questions they will ask you, and for every question, every answer that you give, you should prove it. Okay, for example, they will ask you, is this non-regular? In the interview they will ask you, is this non-regular? What you will say? You will say yes. The next question they will ask you, prove it. Give a proof. Is this clear? So remember this point, what I am saying? I am saying that these proofs are very simple, extremely simple. These proofs are simple. Also, they will help you if you get this type of rank. For example, if you want ISC, then direct admission you can get if you have rank under 50. If your rank is under 50, top 50 will get direct admission. Top 50 will get direct admission. But if your rank is from, I can say from 60 to, if your rank is from 60 to 900, if your rank is here and you want ISC, you can still get ISC through interview. If you want ISC with this rank, then you can still get ISC with interview. And in the interview, they will ask you the proof. Whatever comes out of your mouth, they will ask you proof. If you say anything that, sir, this will happen, they will ask you prove it. Okay, so that is the reason I am saying, why we teach these proof. What is the reason we are teaching these proof to you? What is the reason? The reason is very simple, because in top 60, only 60 people will come. By chance, in the GATE exam, if your rank is under 1000, then we want to make sure that you will go to ISC, IIT. Because ultimate target is GATE rank or IIT, ISC. What is the ultimate target? The ultimate target is IIT, ISC. Okay, that is the ultimate target, right? So we want to make sure that if you get your rank, okay, under 1000, then we want to guarantee, like, okay, if some students are going to interview of IIT, ISC, then Go classes students must be selected in this interview. Are you getting my point? Okay, so please understand, that is the reason we teach everything with proof. That is the reason. Okay, this is the only reason we teach everything with proof, because we want to make sure that Go classes students must go to IIT, ISC if they get rank under 1000. Okay, so this is the idea. Now let me tell you, and remember, these proofs are very easy. All these proofs, these are extremely easy proofs. So now let's see the next language, and let's prove it. Okay, before going to the next language, can you notice what is happening here? In this language, can you notice what is happening? In this language, one interesting thing. So the formal proof we have seen in this language, that is a power n, b power n, where n is greater than equal to 0 or maybe 1. Okay, so this is your language. You can notice the formal proof we have seen, right? Formal proof we have seen. Formal proof done. Okay, we have done the formal proof. But you can notice in the formal proof, actually, why this is non-regular. Informally, why this is non-regular? Informally, every time in the GATE exam, you will not apply the formal proof. Informally, why this is regular? While L is regular, like what is happening? Why L is non-regular? Why L is not regular? What is happening? Because what is the reason? Because the reason is you need to keep track of infinite possibilities. Okay, remember these guests that we have created, these infinite guests that we have created, who are they? These infinite number of guests, who are they? These infinite number of guests, who are they? These are the possibilities we need to keep track of. These are the infinite possibilities we need to keep track of. Yes or no? These are the infinite possibilities. These are the infinite possibilities DFA needs to keep track of. DFA needs to keep track of. DFA needs to keep track of. Remember, for this language, if you want to accept this language, then DFA must keep track of infinite possibilities. DFA need, okay, for example, actually, look at this language. Just for a moment, look at this language. A power n, B power n. This is your language. In this language, what is happening? This is happening. See, first of all, in this language, this type of strings are there, like AB, like A square, B square. If you have 3A, then you have 3B. If you have 4A, then you have 4B. Okay, so like this. Now you can notice, let us assume you want to recognize this language. You want to recognize this. Let's assume you want to recognize this language. Now you tell me, on the input tape, at any point of time, if you are here, on input tape, you tell me on input tape, if you are here, do you know what is coming here? Do you know what is here? Do you know what is here? This is unknown, right? This is unknown. Okay, you don't know what is here. But do you know what is here? But do you know what is here? Yes. Okay, this you know, this you know, this you know. Okay, this you know, this is known. You know what is here, but you don't know what is here. Now you can notice one more thing. See, here, actually, now just think about it. You want to accept this language. This is the language that you want to accept. Now, if you want to accept this language, then you need to keep track of these possibilities. So for example, if you see some A's, okay, if you see some A's, so now you can notice that what will happen here in this language, what will happen? If you are here, do you need to remember? Let's assume you are here. Okay, do you need to remember how many A's you have seen? Do you need to remember how many A's you have seen? Do you need to remember this exact number? Do you need to remember this exact number? Do you need to remember this exact number? This exact number, do you need to remember? Do you need to remember this exact number? Yes. Why? What is the reason? The reason is very simple, that because ultimately you want these many B's. Ultimately, you want these many B's because number of A's must be same as number of B's. Okay, so this exact number you must remember. Okay, so for example, let's assume now you are here. Now you are here. So this exact number 7, should you remember? Should you remember this exact number 7? In this situation, should you remember exact number 7? This exact number 7, should you remember? Must you? Okay, tell me, must you remember this? You must remember this, right? Because now you know that, okay, once the b will come, then 7 b's should come. Okay, now what you will do, you will check, okay, 7 b's should come, 7 b's should come. So you can notice this is the idea. Okay, you have this in mind. So what I'm saying, this is what I'm saying, can I say that these are the infinite possibilities you need to remember, because you need to remember exact number of a's. This exact number 7 you need to remember. Similarly, this exact number 4 you need to remember. If you are here, then this exact number 7 you need to remember. So can I say these are the infinite possibilities you need to remember? Can I say these are the infinite possibilities? Okay, infinite possibilities that needs to be remembered. That needs to be remembered. So can I say, for example, these are the infinite possibilities like a power 1, a power 2, a power 3, and so on. So these are the infinite possibilities that need to be remembered. Yes or no? We need to remember them. We need to remember exact number of a's. This exact number of a's we need to remember if you want to accept this language. Okay, so these are the infinite possibilities that we need to remember. Okay, let me tell you some things. Like some students, what they do, some students, they think like this. If you ask them why this is non-regular, then what they will say? They will say there is a comparison. They will say there is a comparison because number of a must be equal to number of b. Okay, yes or no? Here you can notice there is a comparison. Basically, whatever is this number, okay, this number must be the same. This number must be the same. So they will think that there is a comparison, and they will say that because there is a comparison, so this is non-regular. Okay, because there is a comparison, so this language is non-regular. So this language L is non-regular. Now, after some time, I will tell you that this is wrong. I will tell you many languages we will see. I will give you at least 2-3 languages, or maybe 4-5 languages. I will give you where there will be comparison. There will be comparison, but still your language will be regular. So there will be comparison, but still the language will be regular. So this is wrong. So this is actually wrong. What should be the correct answer? The correct answer is yes, that is fine, comparison, but infinite possibilities you need to keep track of. Infinite possibilities. I can say there is a comparison, and you can notice there is a comparison, and very important thing, this comparison is fine, but you should find infinite number of possibilities. You must find out infinite possibilities that need to be keep track of. Infinite possibilities that you need to keep track of. Is this clear what I'm saying? Infinite possibilities that you need to keep track of. Okay, so in any language, if you have infinite possibilities that you need to keep track of, then I can say that is non-regular. Okay, for example, in this language, these are the infinite possibilities, yes or no? Like these strings are the infinite possibilities. These infinite guests, these are the infinite possibilities that we need to keep track of. Do you agree or not? Tell me. Because these are the infinite possibilities. Remember, these are the infinite possibilities. All these a square, a power 3, all these are the infinite possibilities, and we need to keep track of. What is the reason we need to keep track of? Because the exact number we need to remember. We need to remember this exact number. Okay, so these are the infinite possibilities we need to keep track of. I hope this point is clear. Tell me. So these guests that we are creating, this set S that we are creating, the infinite number of guests that we are creating, these are nothing but infinite number of possibilities that we need to keep track of. Infinite number of possibilities which we need to remember. And in any language, if you can create infinite number of possibilities, if you can guarantee that there are infinite number of possibilities we need to remember, then you can say that that language is non-regular. Okay, so remember, this is very important, that so you need to keep track of unlimited number of possibilities. Unlimited number of possibilities you need to keep track of, and This you cannot do using finite number of states. That is the reason this language is non-regular. Now let's move on to the next question. In this question, do you need to remember? Tell me, is this language regular? This language, is it regular? W, let's assume your alphabet is 0, 0,1. Let's assume your alphabet is 0,1. And we are saying even number of zeros. Is it regular? Is it regular? So yes, you know this is regular. But let's assume this is the argument. You know this is regular. This language is regular. Okay, let's assume some student is saying this is student number A. Student A. Student A is saying that, sir, I need to keep track of infinite possibilities. Sir, I need to keep track of infinite possibilities. I need to keep track of infinite possibilities. I need to keep track of infinite possibilities. Okay. And you ask which infinite possibilities, then what he will say? He will say basically even number of zeros I want even number of zeros. So I need to remember how many zeros I have seen. I need to remember how many zeros I have seen. Yes or no? I need to remember how many zeros I have seen. Agree or not? You need to remember how many zeros I have seen. So these are the infinite possibilities. I need to remember how many zeros I have seen. So these are the infinite possibilities that I need to keep track of. Is this argument correct? So can I say, so non-regular. So L is non-regular. Is this argument correct? Is this correct argument? What is the flaw in this argument? This argument is wrong. So this is the wrong argument. This argument is wrong. What is the reason? What is wrong in this argument? Tell me, what is the wrong in this argument? Because only two possibilities we need to keep track of. For this, actually, we don't need to remember number of zeros. Remember, we don't need to remember number of zeros. We don't need to remember number of zeros. Basically, we only need to keep track of. We only need to remember even or odd. We only need to remember even number of zeros, okay, or odd number of zeros. We only need to remember this. So only two possibilities we have to keep track of. Is this point clear? So remember, some student is saying that, sir, I need to remember how many zero I have seen because I want even number of zero. So I need to remember how many zero I have seen. Okay, but you can notice this is wrong because you only need to keep track of two possibility, even number of zero, odd number of zero. Only two possibility you need to keep track of. Okay, so this language is actually regular. Now let's come to this question. So the template that we have seen, let's apply this template on this question. Let me ask you one more question. Consider this 0 power m, 1 power n. First of all, is this regular? 0 power m, 1 power n. Is this language regular? This language 0 power m, 1 power n. So this language is definitely regular because actually this is A star B star. Okay, this is A star B star. This is regular. This is ultimately A star B star. Any number of A followed by any number of B. Basically, I can say 0 star 1 star. This is your language 0 star 1 star. Okay. Now you tell me what about this language? This language we have already seen non-regular. This language we have already seen. Now let's see this language. Equal number of 0, equal number of ones. Okay. What about this language? Are these two languages same? Tell me, are they same? These two languages, are they same? Equal number of 0, equal number of 1. Are they same? No, not same. They are not same. They are different. Okay, because here you can have zeros, ones in any order. So remember, this language is your W. W belongs to 0, 1 star. And we are saying that number of zeros in W is equal to number of ones in W. Okay, now we want, first of all, you understand this language. This language is basically, I can say number of 0 must be same as number of ones. Number of zeros must be same as number of ones. So this type of strings you have in this language. Okay, this type of strings you have in this language. Now, in this language, can you give me infinite number of, tell me, can you give me infinite number of guests? So in number of 0 must be equal to number of 1. Number of 0 in this W must be equal to number of 1. Okay, now prove that this is non-regular. prove this is non-regular. Let's prove it is non-regular. C is non-regular. So how to prove this? The same template, exactly same template I am going to do. So what I will do? Exactly same template. What is the first step in this template? What is the first step? The first step is assume C is regular. Assume C is regular. So first step is assume C is regular. If it is regular, then what it means? If it is regular, then what it means? There is some DFA. There is some DFA. And every DFA has finite number of states. Every DFA has finite number of states. So you have finite number of states. I am assuming this is regular. So there is finite number of states. So there is some DFA. I am assuming some DFA. Now, can you give me some set? Can you, okay, now consider this set. I am giving you some set I am giving you. Now you consider this set. For example, let's consider this set. Consider this set. B power n. Okay, so 0. Okay, this is your 0 power. So I can say, consider this set. 1 power n, 0. Okay, where n is greater than equal to 1. Okay, now this set you consider. Is this infinite set? Tell me, is this set infinite? Some random set I am taking. Randomly, some set I am taking. Okay, this is an infinite set. So can you guarantee at least 2 of them will go to same state? Can you guarantee at least 2 of them will go to same state? Yes, at least 2 of them will go to same state. Okay, you can guarantee because this is infinite set and your DFA has finite number of states. Your DFA has finite number of states. So what will happen? That at least 2 of them will go to same state. You know. Okay, so let me assume at least 2. Okay, so I can say this is infinite set. So at least 2 of S. At least 2 strings of S. Where they will go? Will go to same state. Will go to same state. Will go to same state. Okay, at least 2 strings. Now, which let me take 2 strings. Assume these 2 strings I am taking. Assume these 2 strings. 1 power n. I can say 1 power m 0 and 1 power n 0, where n is not equal to m. So these are 2 different strings, correct? So I am assuming that these 2 strings are going to same state. Now, is there any problem if they go to same state? Is there any problem? So from the initial state, these 2 strings are going to same state. 1 power n 0, 1 power m 0. They are going to same state. Is there any problem? Is there any problem if they do like that? Is there any problem? Yes, there will be problem. What is that problem? There is the problem. What is the problem? The problem is very simple. Finally, tell me, who will create the problem? Which extension will create the problem? Which extension will create the problem? Which extension is going to create the problem? Consider this extension. Consider this extension 0 power n minus 1. Consider this extension 0 power n minus 1. Consider this extension 0 power n minus 1. It will create a problem. It will create a problem. If you go to non-final state, what is the problem? Tell me. If you go to final state, what is the problem? This extension will create a problem. This extension will create a problem. If you go to final state, what is the problem? Tell me. If you go to final state, then this string will be accepted. Remember, this string where m is not equal to m, you already know. This string is accepted. Should I accept this? Should I accept this? Should I accept this? Should I accept this? This string will be accepted. But okay, this is the problem. This string will be accepted, which is a problem. I should not accept this, right? Because m is not equal to n, I should not accept this. And if you go to non-final state, then there is a problem. What is the problem? Tell me. If you go to non-final state, then 1 power n, 0 power n rejected. Then this is rejected. This is also problem. Should I reject this? Should I reject this? So this is also a problem. So did you understand? Whatever you do, there is a problem. Did you understand? Whatever you do, there is a problem. Whatever you do, there is a problem. Did you understand? Okay. So this proof, this template, did you understand? So finally I can say, so whatever you do, there is a problem. So whatever you do, there is a problem. Yes. So whatever you do, there is a problem. So non-regular. So C is not regular. Tell me, did you understand this proof? Are you finding this interesting? This proof, are you finding interesting? This same template, the fixed template we have, are you finding this interesting? This proof. So we have proven that this language is non-regular. Okay, tell me one more thing. Should I take this as? I am taking this as. Can I take something else? Can I take some other? These are the infinite guests. So can I take some other s? Can I take some other s? Some other set s can I take? Yes, I can take this set also. Okay, I can simply take this set. Okay, I can simply take this set. Yes or no? This set is also infinite set. This is also infinite guest. Okay, will this set create any problem? Again, the same thing. The same thing. Okay, at least two of them will go to same state. At least two of them from the initial state. At least two of them will go to same state. At least two of them, because this is infinite guest. So at least two of them will go to same state. Okay, for example, let me take at least two of them will go to same state. At least two of them. For example, I can say 0 power. Let me take 0 power 100 and 0 power 170 or maybe 173. Okay, so these are going to same state. Okay, because at least two of them will go to same state. You know, at least two of them will go to same state. Now tell me which extension will create problem. Now there is a problem. Now there is a problem. So which extension will create a problem? Which extension will create a problem? Like I can say that 1 power 173 will create a problem. Now, whether you go to final or non-final, there is a problem. Yes or no? Whether you go to final or whether you go to non-final, there is a problem. So there is a problem whether, okay, whatever you do. Will this extension create a problem? Will this extension create a problem? Like for example, this extension, will it create a problem? Will this extension create a problem? This extension, will it create a problem? Will this extension create a problem? Yes, this also will create a problem. This also will create a problem, right? This will also create a problem because you can notice if you make final, then there is a problem. If you make non-final, there is a problem. If you make non-final, what is the problem if you make non-final? If you make non-final, then this string is rejected. Should I reject this? This string is rejected. Should I reject this? This string is rejected. Should I reject this? No, I should not reject. And you can notice if I make it final, there is a problem. What is the problem? This is the problem. This string accepted. Should I accept this? No. So are you getting what I'm saying? So this extension will create a problem. Will this extension create a problem? No, this extension will not create a problem. You can simply go to non-final. There is no problem. This extension will not create any problem. You can simply go to non-final. Okay. So what I am saying basically this is non-regular. Did you understand? So this is the template. Let me come back to the template. What is the template that we have done? See the template that we have done. Template to prove that a language is non-regular. What is the template? Tell me. Template. This is from Stanford. Okay, so what is the template? Find infinitely many strings. Yes or no? Find infinitely many strings that need to go to their own state. Infinite number of guests you find for which you can guarantee that no two of them can go to same state. Means all of them will go to different state. Then it is very simple. Yes or no? Then it is very simple. Using Pigeonhole principle, I can say that at least two of them should go to same state. So this will be the contradiction, and hence I can say language is not regular. Tell me, clear or not? This template is very easy. Yes or no? This template is very easy. Basically, find some. Okay, so this is the template. Okay, to prove L is non-regular. So what you will do? Okay, so this is the template. First assume L is regular. Assume L is regular. Okay, it means there is some DFA. Okay, and you know whatever DFA you have, It must have finite number of states. It must have finite number of states. What is the second step? What is the second step? What is the second step? Find some set S. Find some set S in some infinite set S. Find some infinite set S. Okay, find some infinite set S for which you can guarantee. For which you can guarantee. This guarantee word is important. For which you can guarantee that, okay, for which you can guarantee means, or I can say for which you can prove, for which you can prove that, okay, no, for which you can prove that no two of S, no two of S can go to same state, can go to same state. Correct? Yes or no? Okay, so that no two of S can go to same state. If you do this, that's it. Okay, once you prove this, once you guarantee this, this guarantee is the work. This guarantee is the work. Once you guarantee this, once you guarantee this, that no two of them can go to same state, then what you can say? Then what you can say? Basically, okay, so, okay, basically I am saying that, okay, that's it. So finally I can say that is non-regular. Basically I am saying that, basically prove that, okay, I can say this is the explanation of 2. Remember, this is actually 2, the point 2. Point 2, prove that if any two string of S, if any two strings of S go to same state, then what will happen? Prove that if any two strings of S go to same state, then what will happen? Then problem will happen. Then problem will guaranteed happen. Okay, will guaranteed happen. The problem will guaranteed happen. And then that's it. That's it. And so the third thing is, so L is non-regular. So L is non-regular because L has no DFA. Because L has no DFA. Because L has no DFA. Okay, so this is the template. Now let me ask you, this S is interesting. Can you see that this set S that we are finding, this infinite number of guests, this is interesting. Can I take any random set S? Any random infinite set S can I take? Any random infinite set S can I take? For example, this is your question. Consider this question. A star, A power n, B power m, C power m, where n comma m is greater than equal to 0. Is this regular? Is this language regular? Is this language regular? A power m, B power m. So here you can clearly see there is a comparison. An infinite number of possibilities you have to remember. Yes or no? You have to remember infinite number of possibilities. You have to remember. So first let me give you the informal proof. Okay, the informal proof is this, that this will give you. So there is a comparison. There is a comparison. But what is important thing? Comparison is fine. Comparison fine. After this comparison, can you give me the infinite possibilities we need to remember? Can you give me the infinite possibilities that we need to remember? Infinite possibilities that we need to remember. We need to remember. Can you give me those infinite possibilities which we need to remember? Yes, those infinite possibilities are like this. Any number of A, then B. Any number of A, then B square. Any number of A, B cube. Any number of A, B power 4. Can you notice? These are the infinite possibilities we need to remember. Agree or not? Do you agree or not? These are the infinite possibilities we need to remember. We need to remember so that we can match with number of C. Okay, so these are the infinite possibilities. There is a comparison. Number of B must be equal to number of C, but you can notice these are the infinite possibilities. Okay, like B power 1, B power 2, B power 3, B power 4. These we need to remember. The exact count we need to remember because we need to match the number of B with the number of C. So this exact count we need to remember. So these are the infinite possibilities we need to remember. So this definitely, this language is non-regular. Okay, this is your this is your informal proof. Yes or no? This proof is informal. In the GATE exam, you will use this type of proof, correct? In the GATE exam, you are going to use this type of proof. In the GATE exam, don't apply the formal proof. Okay, so now let's see the formal proof. What is the formal proof? Prove it is non-regular. Prove L is non-regular. Prove L is non-regular. Now, to prove this, if I take this set, Is there, okay, if I take this set, a power 1, a power 2, a power 3, and so on. If I take this set, okay, can you guarantee, will this set work? Tell me, will this set work? If I give you this set, a power 1, a power 2, a power 3, a power, okay, n. For this set, can you guarantee that if two of them go to same state, there is a problem? Will this set work? Will these infinite guests, will they work? This is also infinite set. This is also infinite guest. These are also infinite guests. Will this set work? This set will not work. Why? What is the reason? This set will not work. This set is not going to work. What is the reason? There is no problem, right? There is no problem. From the Q0, if any of them go to same state, is there any problem? Like a power 100 and a power 1000, if they go to same state, is there any problem? No problem. No problem. There is no problem. Okay, there is no problem, because you can notice ultimately number of a does not matter. Number of a does not matter in this language. In this language, number of a really does not matter. So if they are going to the same language, is there any problem? Which extension will create a problem? Can you give me extension which will create a problem? Which will create a problem? Can you give me extension which will create a problem? Give me at least one extension which will create a problem. Can you give me? Can you give me at least one extension which will create a problem? Can you give me? Which extension is going to create a problem? Anyone, please tell me. Which extension is going to create a problem? Which extension is going to create a problem? No extension, right? Okay, no extension creates problem. I can say no extension creates problem. Creates contradiction. I can say no extension creates contradiction. Can I say creates contradiction? There is no problem, I can say. So I can say there is no problem, right? This is what I'm saying. Did you understand this? So this set will not work. So can you notice, randomly you cannot take a set, because no extension can create a problem. In this situation, no extension. Whatever extension you take, whatever. For example, if I take this extension, then I can go to non-final state. Yes or no? If I take this extension, then I can go to non-final state. No problem. So if I take, again, there is no problem here. I can simply go to non-final state. And if I take this extension, for example, b power 100, c power 100, then I can go to final state. Again, there is no problem. Correct or not? There is no problem, whatever you do. So I can say this set will not work. Do you agree that this set will not work? So no extension. So I can say, so this set s equal to a power n, okay, where n is greater than equal to 1, this set will not help in the proof. Will not work. This set will definitely not work. Do you agree? So randomly any infinite set you cannot take, because this set is not going to work. Which set will work? So which set is going to work? So which infinite guest will work? Remember, these guests are good, right? I can say these are friendly. These are good guests. These are good guests. They can go to same, they can share, they can go to same state. They can go to same state. No problem. Okay, they can happily go to same state. Okay, so these guests have no problem. They can happily go to same state. So which infinite guest will create the problem? Who are the mama and chacha? Who are the mama, chacha, tau, whatever? Okay, Jiza. Yes. Who are the Jizas? Who are the son-in-laws? Maybe son-in-laws or brother-in-law. Who are those? Who are the Fumfaji? Yes, find the Fumfaji. This is the point. Okay, so these are good guests. Okay, these are friends. These are your friends who will not create any problem. These are your friends. If they create any problem, you can kick them out from the wedding. Okay, okay, basically these are your friends. You don't care about them. Okay, now, so who are the Fumfaji? So find infinite number of Fumfaji, infinite number of guests who will create a problem. Can you find the Fumfaji in the wedding? So tell me, like this will work. For example, I can say, can you notice I can say a b power 1, a b power 2, a b power 3. This will work. This set will work. Yes or no? basically a b power n, where n is greater than equal to 1. This set will work. This set will work. Any two of them cannot go to same state. Yes or no? This set will work. Any two of them cannot go to same state. Any two of them cannot go to same state. Cannot go to same state. Cannot go to same state. Why? Because the problem will happen. If any two of them go to same state, see, if any two of them go to same state, then problem will happen. If any two of them go to same state, for example, if this and this go to same state, if this and this, they go to same state, problem will happen. Which extension will create the problem? Tell me. Problem will happen. Which extension will create the problem? Whatever you take. Sorry, not whatever. Not whatever. Some extension will create a problem. There is some extension. There is some extension which will create a problem. Can I say? Some extension will create a problem. Not all. Some extension will create a problem. Will create a problem. So can you give me that extension? Yes, you can easily give me that extension. That extension you can give me, for example, c power 100. Okay, give me c power 100. So this extension will work. If you make it non-final, there is a problem. What is the problem? Tell me. If you make it non-final, there is a problem. What is the problem? A b power 4, a b power 100, c power 100 rejected. C power 100 rejected. Should I reject this? Should I reject that? Tell me. Should I reject? No, I should not reject. And if I go to final state, then there is a problem. Then there is a problem. What is the problem? The problem is a b power 41, c power 100 accepted. So that is also a problem. So whatever you do, there is a problem. So whatever you do, there is a problem, correct? Whatever you do, there is a problem. So this language, a star, b power n, c power n, where n is greater than equal to 0, this is non-regular. Are you finding these proofs interesting or easy? Like, okay, tell me, is there any problem in these proofs? Are you finding anything difficult to understand? Are you finding anything difficult to understand? This is like a game. Finding this set S is like a game. Finding this set S, this is like a game. Okay. Anirudh, is there any problem? Anirudh. The same template I am applying. Okay, repeatedly. Now let's see this one. This problem. Can you give me set S? For this a power. So this is the problem. For this set, can you give me set S? A power m, b power n, m is greater than n. This is your language. Your language is a power m, b power n, where m is greater than n. First of all, informally, is this non-regular? Informally, you tell me what will happen. Informally, this is non-regular. What is the reason? Informally, this is non-regular. Because again, there is a comparison. Again, there is a comparison. But this comparison is fine. Remember, this comparison is there. That is fine. Comparison is fine. But you need infinite number of possibilities. Infinite possibilities. Give me infinite possibilities. You definitely need to remember. Give me infinite possibilities. You definitely need to remember. Give me infinite possibilities. You definitely need to remember. Give me infinite possibilities. See, this comparison is fine, but after some time, okay, in the next lecture or maybe after a few days, I will give you many examples where comparison will be there. Still, it will be regular. Okay, please understand this point. Very important. I will give you some languages where comparison will be there, and you will answer that it is non-regular, but still it will be regular. Okay, so this is the 2 points. Comparison will be there. Your answer will be non-regular, but actual answer will be regular. So tell me, so this method is not correct, right? Saying that comparison, only comparison, and saying giving the answer, that is not correct method. Agree? There is a GATE question in which there is a comparison, and 99.99% students, they give the answer non-regular and the answer is regular. So what is the correct method? If you want to apply the informal method, if you don't want to apply the formal method, because formal method will take time. if you want to apply the informal method, then what is the correct method? Comparison is there, but find infinite possibilities that you need to remember. Now let me tell you one thing. That gate question that I am talking about, in that gate question there is comparison, but still the language is regular. What is the reason? The reason is you cannot give these infinite possibilities. If I ask you, give me infinite possibilities that I need to remember, you will not be able to give me. Are you getting this point? So this infinite possibilities, if I ask you, this is important. So comparison is fine, but you should give me infinite possibilities that we need to remember. Did you understand this point or not? Please tell me. Because remember, this is a gate exam question I will take. Okay, several gate exam questions I will take. There is one gate question and some other extra questions I will take where there will be comparison. Your answer will be non-regular, but the actual answer will be regular. And if you want to give correct answer, okay, if you don't want to make any mistake, then what you can do, just give me infinite possibilities. If you can give me infinite possibilities and there is a comparison, means comparison is also there, and you can give me infinite possibilities, okay, then answer will be non-regular. Okay, but if there is a comparison but you cannot give me infinite possibilities, then answer will be, then basically you should think, then you think twice. Okay, so let's see this. So tell me, what are the infinite possibilities that we need to remember? Can you tell me what are the infinite possibilities we need to remember? See, we need to remember these infinite possibilities like a power 1, a power 2, a power 3, a power 4. This exact number do we need to remember? Just tell me this point. Just tell me this point. Just tell me this point. This exact number do we need to remember? This exact number. This exact number do we need to remember? Tell me. Do we need to remember this exact number? This exact number do I need to remember? Yes. Okay, because this exact number I need to remember because I need to see how many bees will come. I need to see how many bees will come. Okay, so this exact number I need to remember. Is it clear? Is this clear to everyone? So this exact number I need to remember. I need to remember this exact number. The idea is very simple. We need to remember the exact number. Okay, so this exact number of A's, we need to remember. So because of this exact number of A's, what will happen? These infinite possibilities you will get. Okay, so this is the informal proof. So informally, this is non-regular. So this language is non-regular and this is the informal proof. Now let's see the formal proof. Give me the set S. Okay, just give me the set S. Now you are expert. Just give me the set S. Okay, consider this set S. N greater than equal to 1. Consider this set S. Okay, now you tell me, can I say any two of them should go to different states? Can I say any two of them should go to different states? Tell me. Any two of them should go to different states. If they are going to same state, is there any problem? If they are going to same state, is there any problem? If they are going to same state, for example, a power 5, a power 6. If they are going to same state, is there any problem? Which extension will create problem? Tell me, which extension will create problem? Which extension is going to create a problem? Okay, there exists an extension which will create a problem. So which extension is going to create a problem? You can clearly see this extension will create a problem. Okay, you can clearly see this b power 5. This b power 5, it will create a problem. Why this will create a problem? Because if you make it non-final, then there is a problem. What is the problem? Tell me. If you make it non-final, there is a problem. What is the problem? Okay, this will be rejected. Should this be rejected? Should this be rejected? Should this be rejected? Tell me, should this be rejected? No. So this is a problem. Can I say this is a problem? This should not be rejected. So this is a problem. And if you go to final state, there is a problem. If you go to final state, there is a problem. What is the problem? A power 5, B power 5 accepted. Is there any problem? Yes, again, there is a problem. Should this be accepted? Should this be accepted? There is a problem. This should not be accepted. So did you understand? This extension will create the problem. Will this extension create the problem? B power 3. Will this extension create the problem? Will this extension create the problem? There is no problem. Just go to final state. Just go to final state. There is no problem. So this extension is not going to create a problem. Okay. This extension creates no problem. Is this clear to everyone? Let me know. Is this question clear? So you can notice what we have seen. What we have seen. Every two of them should go to different states. These are your Fumfajis. You can notice. So every two of them should go to different states. Every two of them should go to different states. Every two of them should go to different states. How many people are there? Every two of them should go to different states. But how many people? Total infinite people. So every two of them should go to different states. And okay, poor DFA cannot do this. Poor DFA cannot do this. There is a movie in the childhood. I have seen the movie. There is a Mata Vaishnav Devi movie. Have you seen that movie? There is a movie. Okay, anyway, in the childhood, I saw this. So there is a movie, Mata Vaishnav Devi. You can check it out. Okay, so in this movie, okay, Mata Vaishnav Devi. Okay, so in this movie, what happens? So there is a I can say follower of Mata Vaishnav Devi. Okay, a true follower, a very good follower. Okay, and he invites some people for lunch or dinner. So he invites some people for dinner, but he has a small room. Okay, then what happens? A lot of people come. A lot of people come. Then okay, so he has a very small room, but a lot of people come. Then what happens? Because he is true follower of Mata Vaishnav Devi. So Mata Vaishnav Devi, what happens? So this room gets bigger and bigger. So this room gets bigger and bigger. This room gets bigger and bigger. Okay, so you can notice this type of facility DFA does not have. Only God can do. Yes or no? This type of facility DFA does not have. Basically, DFA cannot do this. So you can notice if infinite number of people are coming, then DFA cannot accommodate those people. Infinite number of people are coming, and also they are saying we want different rooms. Okay, infinite number of people are coming, and they are saying, and okay, see, remember, infinite number of people are coming. Here you can notice infinite number of people are coming, and they want different rooms. So poor DFA cannot do this. Is this clear? Poor DFA cannot do this. So this is the idea. Now what about this language? The second language, A power M, B power N. Prove that this is non-regular. Okay, A power M, B power N. Let's prove this. This language, A power M, B power N, where M is less than N. Where M is less than N. So the same idea, yes or no? The idea is the same. So what will happen? So idea is same. So this is also non-regular. The same idea, this is also non-regular. And what are the infinite possibilities that we need to remember? What are the infinite possibilities? So there is a comparison. Of course, there is a comparison. But comparison is fine. But which infinite possibilities you need to remember? Needs to be remembered. Which infinite possibilities you need to remember? So these infinite possibilities you need to remember. For example, do you need to remember this exact number of A's? Just tell me this point. This exact number of A's, do you need to remember? This exact number of A's, like this exact number of A's, do you need to remember? Do you need to remember this exact number of A's? Just tell me this point. Okay, at this point, do you need to remember this exact number of A's? Yes or no? Correct. Needs to remember this exact number of A's. We need to remember so that number of B can be bigger than this. Okay, so what are the infinite possibilities? I can say A power 1, A power 2, A power 3. Okay, these are the infinite possibilities that we need to remember. Correct? Yes or no? Agree or not? So these infinite possibilities we need to keep track of. These infinite possibilities. Okay, we need to remember these infinite possibilities. We need to remember. Okay, so I can say this exact number we need to remember. So that is the reason, and you can have this type of situation. So this is non-regular. Now, what is the set S for this language? A power M, B power N, where M is less than N. Again, this set S will work. This set S, A power N. Okay, this set will work, correct? Yes or no? This set will work. What will happen in this set? This set will work because if any two of them are going to same state, if any two of them are going to same state, then there is a problem. What is the problem? Which extension will create a problem? Which extension will create a problem for this is a power 1, a power 10? Which extension will create a problem? You can notice this extension a power 6 will create a this b power 6 will create a problem. This b power 6 will create a problem. Yes or no? This b power 6 will create a problem. Whatever you take, final or non-final, okay, you take final or you take non-final, this will create a problem. Okay, so you can notice if you make non-final, this will be rejected, but this should not be rejected. If you make final, this should be accepted, this will be accepted, but this should not be accepted. This formal proof is also very easy. Can you notice? This formal proof is as easy as the informal proof. Can you notice? The formal proof is as easy as the informal proof. After the practice, once you do enough practice, this formal proof is very easy, extremely easy. And this formal proof will give you the guarantee. Okay, so very simple. I hope this lecture, so, okay, this is enough. But let me ask you some questions. One last question let me take before going. Let's take this WW. Or maybe in this language, will this set work? In this language, in the same language, a power m, b power n, where m is less than n. In this language, will this set work? Some set I am giving you, which set will work? Which infinite set S will work? Set S will work. Basically, which infinite set? Basically, what I'm asking, what this means? Basically, what I want to ask, any two of them will go, we need to go to different states. Basically, okay, a set S whose any two elements, okay, must go to different states. Must go to different states. Okay, must go to different states. Basically, any two elements must go to different states. So tell me, which set will work? Tell me, will this set work? Will this set work? Tell me, will this set work? Is this set going to work? This set is not going to work. This is an infinite set. This set is not going to work. Why? What is the reason? This set is not going to work. What is the reason this set is not going to work? Why this set will not work? Just tell me this point. So the answer is no. Because you can directly send them to non-final. Okay, yes, all of them you can send to non-final. All of them you can send to non-final. All of them. Okay, for all W belonging to S. So this set can never work. Okay, because all of them you can just directly send them to non-final. So this set will not work. Basically, always create a set. What you do? Okay, always create a set S such that no two strings. If any two strings, okay, create a set S such that if any two strings go to same state, if any two strings of S go to same state, then what should happen? Of S go to same state, then problem happens. Then some extension creates the problem. Then some extension creates the problem. Okay, so this is the idea. So this type of set you create. So I am giving this as a homework. In all of them you need to create set S. Okay, for all of them you need to, okay, this is the homework I am giving you. In this homework, what you need to give me. So what you need to tell me, please understand what you need to tell me. So you need to give for each you need to create two set S, two different sets S, okay, which will work. Okay, for each of them you need to create two sets S1 S2 which will work. Two infinite sets, remember, two infinite sets S1 S2 you need to create. Two infinite set S1 S2 you need to create, which will work. Also you need to create one set S, one infinite set S which will not work. Which infinite set S which will not work. Is this clear? Which will not work. Tell me, is this clear to everyone? This is the homework. Okay, for each of them, you create set S, S1, S2, which will work. So two different set you create, two different set which will work for each of them. And for each of them, you create one infinite set which will not work. I think this is a nice practice. Yes or no? These many questions, I think this is a nice practice if you do this. So let me tell you what we have seen so far. That is the idea of Myhill Nerode theorem. What we have seen so far. So far, what we have seen. In tomorrow we will continue. Okay, tomorrow we are going to continue. But what we have seen so far, that is idea of Myhill Nerode theorem. So far we have seen idea of Myhill Nerode theorem. Tomorrow I will tell you the formal statement of Myhill Nerode theorem. So far what we have seen, that is your Myhill Nerode theorem. Okay, that is basically Myhill Nerode theorem. But the formal statement I will tell you tomorrow. But whatever we have seen, this is your Myhill Nerode theorem. Did you understand this? Tell me. So far what we have seen. So far we have seen. So far we have seen what we have seen. So far what we have seen, that is idea of Myhill Nerode theorem. That is the idea of Myhill Nerode theorem. So this idea we have seen. And tomorrow in the next class, we will see the formal statement. But I hope you are liking it. Okay, because using this Myhill Nerode theorem, you can prove regular also, you can prove non-regular also. Both of them you can prove. Okay, you can prove a language is regular. You can also prove a language is non-regular. So this Myhill Nerode theorem, this is better than pumping lemma. Yes or no? We have seen pumping lemma. Using pumping lemma, you can prove non-regular, but you cannot prove regular. Using pumping lemma, you cannot prove that a language is regular. But using pumping lemma, you can prove that a language is non-regular. Because remember, this Myhill Nerode theorem, this is very good. Using Myhill Nerode theorem, you can prove a language is regular. You can also prove a language is non-regular. Okay, so this Myhill Nerode theorem is basically, I can say, two-way statement. So this Myhill Nerode theorem statement we will see tomorrow. So please tell me if anyone has any doubt. This lecture was very important. This was extremely important lecture because from this lecture, okay, you can solve at least 100 questions in the GATE exam. Now, whatever question comes in front of you, like, is this language regular? Is this language non-regular? So what you will do? If a question comes, is this language regular? Then what you will do? If you want to prove a language is regular, then what you do? Either you create NFA, or you create DFA, or you create regular expression. If you want to prove a language is regular, then these three things you can do. Either create DFA, or create NFA, or create regular expression. And if you want to prove a language is non-regular, then what you will do? Then this idea you apply. This idea that we have seen, just apply that idea. Okay.